right, guys, we're going to go ahead and continue with our simulations lesson and cover the second type. And so we're doing the Chapter 11 notes, Part 2. So let's take a look at how these are different. So here we are in our notes. Here's the fourth one. You just did number 3 on your own. Okay? All right. Many couples want to have both a boy and a girl. If the couple decides to continue to have children until they have at least 2 boys and 2 girls. Okay? Assuming boys and girls are equally likely, describe and conduct a simulation, 5 trials, estimate the average number. So we're estimating that average number of children that the couple would expect to have to get at least 2 boys and 2 girls. Okay? Now, if you remember from last December, we would have these ones where we go until the first success. And those were our geometric problems, where we would have failure, 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 first success, done. Okay? And so you would go different lengths of time because it would say you don't have the success until this one, or how long do you expect to go until that first success. This problem is a case that we cannot represent with our simple geometric methods. And the reason is because it's not just one success. It's 2 boys and 2 girls. Okay? So this is an example of a more complex problem where our option is to do the simulation and we don't have the tools right now to do it theoretically. Okay. So here we go. So we have each digit represents, let the numbers be. And so let's see, we got boys and girls, they're equally likely. So that's 50% chance stuff. So I'm thinking 50%, I can just do, you could do something like use numbers 1 and 2 and ignore all the rest of the digits. I think I'm going to use just single digit numbers, and I'll probably end up doing, say, odds and evens, because that's half and half. You could do 1 to 5 is one thing, and 6 to 9 and 0 is the other. Okay, so whichever way, and you might even consider, you might try doing it differently than me and see how yours ends up. So, but we're going to let each 1-digit number represents a child. And so I'm going to let the odds be the boys, odd boys, and the evens, now this includes 0, be the girls. I think technically 0 is not considered an even. I don't remember number theory stuff like in that. Okay. So there's my each digit represents, let the numbers be. Use the random number table below and start at the top left-hand corner. Use the random number table below. And start at the top left corner. All right. A trial consists of, what do you ignore? Okay, so when we talk about ignoring, were we ignoring any of our 10 single-digit numbers? And that would come into play if, say, we decided to just say, use the numbers 1 and 2 and ignore everything else. Okay, and then we also want to consider if we ignore repeats. So we'll talk about that. All right, but let's look. These are type 2 problems where we are estimating an average. In fact, up here in the question, these are different than the ones on the other video because these are estimating the average number of items we will look at, or the children they will have, until we get what we are looking for. So down here, a trial does not stop until you get what you were looking for. Okay, example. Have children until you get at least 2 boys and at least 2 girls. Okay, go to houses until you find one that has both a cat and a dog. Open college applications until you find 3 with the SAT score of 1350 or more. Okay, so you may have to have different amounts of children depending on the randomness of the numbers. All right, so a trial consists of having children until getting at least 2 boys and at least 2 girls. Okay, that's what the name of this game is for this couple. Now, let's think about this. When we're coming down here and we say, okay, here we go. That couple right there had a 9. That's an odd, so that's a boy. Okay. Then they had a 6. That's an even, so that's a girl. And then number 1, that's an odd. That's a boy. Number 5, that's an odd. That's a boy. Question: can this repeat occur? What's that saying on this child right here? Can that 5 occur again? And the answer would be yes, if having each child is independent of the other, and each time you have the next child, there's still a 50% chance of boys and 50% chance of girls. And I think we have that situation here. I think each time they pick a new number, you're back to all 10 digits are applicable. Okay, so yes, that was again another boy. So then there's another boy, and 0 was our girl. Okay, whoa. So that couple had to have 8 children to get there at least 2 boys and 2 girls. See, I stopped right there because I had 6 boys, yikesies, and then 2 girls. Okay, all right. So up here, you may make note. I always do. I always address repeats right here when it says, what do you ignore? So repeats are okay because each child is independent of the other child. Each child is independent of the other child in their probabilities of occurring. Now, a trial consists of what do you ignore? Your response is critical. What do you look for? Okay, so our response is the number of items you had to look at to get what you were looking for. So, how many items? Oh, this is not correct right here. My bad. I have that written wrong. So in this case, yikesies. Okay, so in this case, the example is going to be the number of items to get 2 boys and 2 girls. Okay, so the number of items to get 2 boys and 2 girls. The number of items, number of houses you had to go to get at least a cat and a dog, and so on. So that is why I put an 8 right there. Because that couple that's the response I'm looking for. That couple had to have 8 children to meet their goal. So that's the response. The response is the number of children the couple had to have at least 2 boys and 2 girls. Okay? All right, so at this point, I want to stop. You're going to, we just did one trial. And so I want you to do 4 more because it said carry out 5 trials. So let's go ahead and pause and do your rest of your trials, and then we'll meet back together and see if we got the same thing, because I could make a mistake too. So let's see how we do. All right, so I've got my 5 trials complete, and I put the numbers on top of how many children the couple had to have at least 2 boys and 2 girls. Okay, so it looks to me like next is the statistic. Your response is critical. What will you look for? Get your statistic, man, 'cause I want to know. According to your simulation, about what does this show? All right, so let's talk statistic. In our previous problems on video 1, it was the average, it was the proportion that were yes out of the total trials. So it was a proportion number. Now it's because we were estimating probabilities or estimating proportions. These problems, however, are estimating the average number of something. So therefore, the statistic is the average number of items that you had to look at to get what you wanted. So in this case, to average our numbers, we're going to be adding up those 5 values and dividing by the 5 trials. Okay, so that's 25 divided by 5. So that number is 5. So on average, according to my simulation, the couple will have about, according to your simulation, about, what does this show? About 5 children on average to get 2 boys and 2 girls, at least 2 boys and 2 girls. Now, um, question, because had we done actually 10 trials, that number would have been different. I think it was like 5.3 or something, or 5.5, I think it was. So, question, if my average had come out to be a decimal of 5.5, can I say the couple needs to have 5.5 children according to my simulation? Can I say that? Because you can't have half a child, okay? And that answer is yes, because this is the results on average, not an answer to any one specific event, what's happening on average. Okay? All right, very good. So see, that's going faster now that we've done several of these. So let's take a look at this next one. And I'm just going to let you start it a little bit and see what you come to. I think I need to fix this down here. I think, again, I had the typo here, so you want to cancel that out. It's just your response is the number of items that you had to get what you were looking for. Okay? All right, let me give you a few moments to write this one out. Read it and write it out. Now, believe it or not, this was one that we could do theoretically, and I think I addressed that at the bottom of the page. Because we were just going until we find one of the households that has what we want. If they had said go until you find 3 houses that have both a cat and a dog, we couldn't have done that. That would not have been then a geometric situation. All right. So we're going to be estimating the average number of households you expect to have to go to until you find one that has the cat and the dog. So my one-digit numbers are a household. 20%, I just needed the one-digit numbers. So I did 1 and 2 are a house with a dog and a cat, and the rest are the others. So what's my trial going to consist of? My trial consists of going to houses until I find one with a dog and a cat. Okay, so let's now think about the other thing. A trial consists of what do you ignore? Okay, so sometimes that might help you when you go down here to the bottom. That might help you to look at numbers to kind of think about that. So I'm going to come down here and I'm going to do this. Let's see, numbers 1 and 2 are the ones I'm looking for. So that's not 1, not, not, and then ding, 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 ding. Okay. So as I'm going through there, I see I allowed repeats. And is that okay? Because every time I go to another house, does it matter what the other house in front of it had? Okay, so I think that it doesn't. So what I am saying then is that repeats are okay because each house is independent of the other houses. Okay, and so then when they're independent and one's not affecting the other, then repeats are okay. All right, so a trial consists of what do you ignore? Your response is critical. What do you look for? So remember over here, our response is the number of items we had to look at to get what we were getting. And there was that one. So let me think. How many houses did I have to go to? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I had to go to 8 houses to get what I was looking for. Okay? All right, so we're going to pause here. We can go ahead and write that here. Our response for each trial is the number of houses we go to find one with a dog and a cat. All right, so I'm going to go ahead and pause and do my other 4 trials, and then we'll get to come together and do the statistic, which will be the average of that. All right, so there's what I got, and so there's my responses, and so now I'm going to average those, and that will be my statistic, and so I'm going to write that by going my 8 plus 8 plus 2 plus 6 plus 2 divided by my 5 trials is 5.2. Can we go to 5.2 houses? And that answer is no. We cannot go to 5.2 houses. But we accept that number because what we're saying is that according to my simulation, I expect to go to about 5.2 houses on average. That's the key to why the decimals are allowed on average to find one with a dog and a cat. All right, so there we go. Okay, so that finishes out that one. And so that finishes out 2. So it went much faster than the ones in the first video. And so now you try this one on your own, okay? And again, remember that this was wrong in the response. Your response is the number of items it took to get what you were wanting, okay? So then, again, your first actual assignment that you'll turn in for your Canvas this week is this notes, all 6 of these problems done, of which I did 4 of them with you, and you did 2 on your own, numbers 3 and number 6, okay? And then you'll practice, and then you'll do warm-up. All right, so I hope that helps you. We may end up having some WebExes that I offer you guys, so you'll get texts offering that in case you have some questions. But always just email me if you have some questions.